All right, at this point we've looked at graphs of linear functions and more general functions as simply being plots of input or output pairs. We've looked at them as functions. And for functions, this makes a lot of sense. But more generally, we want to be able to define points that lie on the graph of an equation or on an inequality with a simple test or definition. So the connection between graphs and equations and inequalities is a simple one. Any coordinate pair xy that makes the equation or inequality true lies on the graph. So if it is true, it will be on the graph that is given. The entire graph is a collection of all of the x and y pairs that make the equation or inequality true. So we're looking at this equation. Y equals 4x plus 2, and we need to see, does 2, 10 lie on the graph? So we're going to plug 2 in for x. So 4 times 2 plus 2. And we're going to plug 10 in for y. So instead of y equals 4x plus 2, we plug 10 in for y, 2 in for x. So now we simply just solve. 4 times 2 is 8. Does 8 plus 2 equal 10? Yes, 10 equals 10. So the answer is yes, it lies on the graph. Now we're going to use this point with the same equation. So, does 4 equal 4 times negative 1 plus 2? Well, 4 times negative 1 is negative 4. Negative 4 plus 2 is negative 2. 4 does not equal negative 2, so no, it does not lie on the graph. So, for exercise 2, the equation y equals 2x squared minus x plus 5 describes a parabola. The fact that there is an x squared right here means it's going to be a parabola. Remember, a parabola is a graph that has a little curve in it. So it's not going to be a linear equation. It won't be a straight line. So, does the point 320 lie in its graph? So, 20 is going to go in for y. 3 is going to go in for every single x. So does 20 equal, so PEMDAS, parentheses, we don't have anything in parentheses. The parentheses we do have is really just multiplication. Exponents is next. So 3 squared is 9 minus 3 plus 5. So now multiplication. 2 times 9 is 18 minus 3 plus 5. I'm going to move this up here. So 20 equals 18 minus 3 plus 5. 18 minus 3 is 15. 15 plus 5 does equal 20. So yes, this point lies on the graph. Inequalities can also be graphed, and we will concentrate on that in the next lesson. But in this lesson, we can certainly determine if particular points will lie on the graph of an inequality. So for the next 4, we're going to determine if they are true for that inequality. So we're going to plug 4, 1 in. So 1 goes for y, 4 goes for 2. Or goes for x. So is 1 more than 8 minus 5? Is 1 more than 3? No. 2 plus 8, is that less than or equal to 10? Well, 10 is equal to 10, and because of this or equal to, yes, it is part of that graph. Is 2 less than negative 3 squared minus 4? This is something that we have not spent a lot of time talking about, but when you put a number in for a variable, you always put it in parentheses. You'll see that I put it in parentheses up here. You'll see that I also put it in parentheses right here. So what that means is you're taking the whole thing of negative 3 and multiplying that. So this is really negative 3 times negative 3, which makes it positive 9. So is 2 less than 5? Yes, 2 is less than 5. We're going to plug negative 6 in for y. negative 1 in for y, goodness, negative 6 in for x. So is negative 1 more than or equal to, well, negative 6 plus 12 is positive 6 divided by 3. Is negative 1 more than or equal to 2? No, it's not. We can even determine with some additional calculations whether a point is a solution to a system of equations or a system of inequalities. You've studied systems before. Well, actually, you guys haven't spent a lot of time studying systems, but here's what you need to know about systems. A system of equations is a collection of two or more equations joined by the and truth condition. Because the and condition is only true when all of its components are true, the solution set of a system is. So that doesn't really make a lot of sense right now. So let's put it to use. So exercise 4, we have this point of 3, 1. And in order for it to be true for this solution, it has to be true in the first equation and the second equation. So is 1 equal to 2 times 3 minus 5? And is 1 equal to negative 4 times 3 plus 13? So let's check the first one. Is 1 equal to 6 minus 5? Yes, 1 is equal to 1. So it works for this one. Now, is 1 equal to negative 12 plus 13? Yes, 1 is equal to 1. So it works for this one also. So yes, this point is a solution for both of these equations. Most of the time, the word and will not be included as it was above. The assumption will be that by telling you that it is a system, you know that all of the equations or inequalities are connected with an and. So does this point lie in the solution set of the system of inequalities? So remember, it has to be true for both of them. So our first one is 15 more than or equal to 4 times 5 minus 7. And our second one is 15 less than 5 squared minus 10. So first one is 15 more than or equal to 20 minus 7. Is 15 more than or equal to 13? Yes, it is. But remember, just because it's true for one of them doesn't mean it'll be true for both. So now, is 15 less than 25 minus 10? Is 15 less than 15? No. So the overall answer for this one is no. That point will not be in the solution set of both equations. You can even mix equations and inequalities because the answer always depends on whether or not all conditions are met. So let's look at the first one. Is 5 more than 4 minus negative 2 divided by 2? And is 5 equal to 3 times negative 2 plus 11? So is 5 more than, remember you have a double negative here, so that's going to be 6 over 2. Is 5 more than 3? Yes, it is. Now, is 5 equal to negative 6 plus 11? Is 5 equal to 5? Yes, it is. So overall, the answer is yes, because it made both of them true.